This is brought to you by the Alumni Association of PISJ-ES.
Hey guys, in this video we'll be doing some more examples of forces, and I have here a very interesting applet, a Java applet by phet.colorado.edu. Here's the address. I'll also be posting the address in the descriptions, so you can go there and have a look at that, and we'll be predicting some of our answers using some daily life situations, and we'll see whether our calculations are working or not. So let's go to the applet. Here's the applet. If you can see that these are the controls, and I'll be using them time to time. This is the horizontal force, this is the total force, here's the friction, here are the barriers, these are the barriers. You can see this is how they work. If I put on barriers, it will stop here. If I do not, then it will keep moving. So it's better to just put on barriers. And then I have to choose some objects here. So let's see. Let's just choose a file cabinet here, which has a mass of 200 kilograms. Alright. So now we'll be applying some force on it, and we'll be seeing whether, let's just turn off friction first. We'll be seeing whether it gives us the calculated acceleration. So let's see. Let's give it an applied force of 600 newtons. Let's see how it moves. This is the guy. This is the applied force, and since this is the only force, this becomes the total force, and he'll crash at this point. So this is where he crashed, and obviously we know from Newton's third law that if you exert a force here, the object will exert an equal but opposite force. That is the wall force in this case. Now let's see, we applied a force of 600 newtons to a mass of 200 kilograms. Let's see what our calculations tell us. So in the first case, we had a mass of 200 kilograms, and we applied a total force or a net force of 600 newtons. Let's see what the acceleration tells us. So with the same formula, F is equals to ma, the net force is 600 and the mass is 200 times a. So a would be 600 divided by 200, which would give me a 3 meters per second square. So according to our calculation, the acceleration, a constant acceleration of 3 meters per second square. Since this is a constant force, this would be a constant acceleration of 3 meters per second square. Let's just check out what our graph has to say. Okay, this is the time where it collided with the wall, and you can see, let's see if you can, at this point, this is a 3 meters per second square. Let me just clear it again and show it to you. Let's see, let's just put in 600. I'm just saying, you can see it's 600. Let's see. So it's a 3 meters per second square acceleration, and let me just remove the barriers here. So it'll just keep moving with an acceleration of 3 meters per second square. And since this is it's like a constant acceleration, we can also find its velocity at a particular time interval, let's say at 12 seconds. If you want to find out the velocity it has reached at 12 seconds. Let's see what is the relationship between acceleration and velocity. There is only one relationship between acceleration and velocity, which is delta v over delta t is equals to acceleration, which means v minus u divided by t is equals to acceleration. Initial velocity minus final velocity minus initial velocity divided by time is equals to acceleration. Since we have a constant acceleration of 3 meters per second square, and we want to find the velocity at 12 seconds, so t becomes 12, acceleration becomes 3, and initial velocity was 0 because we started at rest, and we want to find out the final velocity at this time. So let's see, final velocity minus 0 divided by 12 is equals to 3. So v is equals to 12 times 3. This should be a 36 meters per second according to our calculation. Let's see what the applet has to say. Now I'm graphing velocity, and we will see when it comes to 12 seconds what is the velocity, whether it is it 36 meters per second or not. Let's see. Let's just continue. Let's just look here, and I'll just pause at 12. There you go. Come on, and yeah, here. So it's about 12 meters per second, not exactly. If I just do it like this, and you would see it was about 36 meters per second at 12. So you see how we found out the acceleration and velocity using just some simple concept. And let's take another example. Let's just take the mass. Let's just keep the mass. Let's just change the mass. Okay. Let's just use a crate instead. Let's use a crate of mass 300 kilograms. And let's just predict some things beforehand. We can say that if it has a mass of 300 kilograms and we apply a force of, let's say, 600 newtons, which becomes net force, since this is the crate of mass 300 kilograms and the only force applied is this one, and there is no friction force. I have just switched off the friction, so there is no, it's a slippery ground, there is no friction here. So in this case, let's see what the acceleration tells us. The acceleration would be calculated with the same formula, F is equals to m times a. The force is 600. Let's just switch the formula beforehand. This would be our formula to calculate acceleration. The force is 600, the net force, the mass is 300. The acceleration becomes 2 meters per second square. Now this would be our acceleration. Let's see if I want to find out velocity at t is equals to 10 seconds with this constant acceleration. The simple formula would be v minus u divided by t is equals to a. So we have to find out v, which is the final velocity. The initial velocity is 0 in this case since it's starting from rest. So this is the initial velocity. And the time taken is 10. The constant acceleration with which the box is moving is 2 meters per second square. So let's see what the velocity is. 2 times 10, which is 20 meters per second. So at time t is equal to 10 seconds, with this mass we will have a velocity of 20 meters per second. So let's find out. So our mass was crate here. Let's just clear this. We're taking this crate here. This is the crate, and we're applying a force of 600 newtons. And we'll be seeing, we predicted the acceleration to be 2 meters per second square and the velocity at 10 seconds to be 20 meters per second. So let's see. Let's find out. The acceleration is 2 meters per second square. Yes, that's perfect. Let's find out the velocity at 10 seconds. Let it come here. It's going over at the same time, but you are not able to view it from here. So let's see. I'll pause it here when it comes to t is equals to 10, and you can see whether we are correct or not. So here it is. Well, it's 19.8 because it's little of that, and if I just it's at 20 meters per second at t is equals to 10.